I'm Dr. Creighton, and in this video we'll be talking about radical equations. The key objective here is just solving equations involving and using radicals. So let's just start off with a nice one. So let's try to solve the square root of x is equal to 3. Now, what a lot of people intuitively know here is that the square root, how to get rid of a square root, is that you would square both sides. So let's just go with the intuitive approach. So in this case here, we're going to square to give us the square root of x squared is equal to 3 squared, which simplifies nicely to x is equal to 9. All right, so that's great. That works out really nicely. And then for these ones, I'm going to make it a point to physically check all of them. This is a case where we actually do. So in this case here with 9, the square root of 9 is in fact 3, so we're all happy there. So the intuitive approach of how do you get rid of a square root? Well, you square both sides works. What about something like the square root of x is equal to negative 3? So again, what I'm going to try to do here is square both sides. So in this case here, I get the square root of x again, quantity squared is equal to minus 3 quantity squared, which again simplifies down to x is equal to 9, which is great, all right? It looks like both of these equations have the solution of x is equal to 9. So I'm going to check my answer again. The square root of 9 is equal to 3, all right? But that's not equal to negative 3. So that's not a solution to this. So in fact, this one we'll see it has no solutions. And then the reason is that the square root of x, if you remember this, has a range being positive. So the range is 0 to infinity. Or saying another way, the square root of x is always a number bigger than or equal to 0. But we're setting this positive number equal to a negative number. There's no way that this positive number for some choice of x can ever get that negative number. Which is why, even though we squared it and got x is equal to 9, when I went to go and check it, it was not a solution. It picked up the positive 3, but not the negative 3. The basic idea here is this thing called the power rule. You notice that when I have the square root, I squared both sides. The power rule says solutions to an equation f of x is equal to g of x are also solutions to f of x to some power n is equal to g of x to some power n. So what's that saying? If you get a solution for some equation here, f of x is equal to g of x, if you take the nth power of both sides, it's still a solution. So what we've been doing here is we've been finding solutions here and then checking in the original. And so that's really what we saw here. So we found that, for instance, with the square root of x is equal to 3, the solution to it being squared is in fact a solution to the original one, all right? But the solutions to x is equal to negative 3, which when you take the squaring goes to x is equal to 9, this is not a solution. And so the statement here is still true, is that this thing has no solutions, and this thing has one solution. So the solutions to the original one, none, or for the square root of x is equal to negative 3, is a solution x is equal to 9, which has more. So when you do this, the big thing is that you can get extra solutions when using the power rule. That's the important bit here. So you always need to check your answer, because if you square an equation, cube it, some other power, you can get extra solutions that you always need to check. All right, so let's get down to this. Let's try to solve the square root of 4x plus 1 is equal to 4. So the thing that I note here is that we already have the radical by itself that's equal to 4. So what the first thing is, I'm going to use the power rule here and square both sides. So in this case here, I get the square root of 4x plus 1 quantity squared is equal to 4 squared. So again, this step here potentially has the ability to add extra solutions. So just be careful, always check your answer. So in this case, we get 4x plus 1 is equal to 4 squared, which is equal to 16. Now solving this nice equation, 4x is equal to 15 by subtracting 1 from both sides. So then x is equal to 15 over 4, which is a fraction, but it's not that bad. So now we have to go and check it. Again, always check in the original equations. Do not check after you do anything to it. Original equations only here. So in this case, we get the square root of 4 times 15 over 4 plus 1. That is equal to the square root. 4 times 15 over 4 is just the 15 plus 1, which is equal to the square root of 16, which is equal to 4. That works. So this is a solution. This is our solution. So let's try this one here. So we want to solve the square root of 25 minus x, then subtracting x is equal to 5. So in this case here, when we use the power rule, the thing we want to do is undo that radical. So the first step is we want to isolate the radical on one side, so that when we square it, we don't have those extra intermediate terms from distribution. So in this case here, I'm going to write this as the square root of 25 minus x is equal to x plus 5. The rationale again is that when I square this side, I just get 25 minus x. If I had that minus x there, you would have extra terms. The radical actually wouldn't go away. So the first step is always to isolate the radical. All right. There are some cases where you might need to do this a couple times and where you can't fully isolate all of the radicals, but you want to isolate at least one of the radicals if there's multiple. So in this case here, we're going to square both sides. This is the square root of 25 minus x, quantity squared, is equal to x plus 5, quantity squared. So this is 25 minus x is equal to, and then this is a spot where I see a lot of you're going quick, you're just going to do this, but you have to actually distribute this out. This side is x squared plus 10x plus 25. You have to distribute. That 10x there in the middle, that right there is a very, very common thing to miss. But now we're down to a quadratic, so that we can solve quadratics. So I'm going to write this as x squared. Adding the x to both sides gives us plus an 11. X, and we have 25 on both sides, subtracting that off, we get 0. So that simplifies nicely. So this factors as x plus 11 is equal to 0. So, by the zero factor property, x is 0 or x is equal to minus 11. So we get two solutions there, which is great. So now we need to check. So I'm going to check the x is equal to 0 first. So plugging it into the original equation here, I get the square root of 25 minus 0, again minus 0. That's equal to the square root of 25, which is equal to 5. That works. So 0 is one of our solutions. So let's check the negative 11. X minus is equal to negative 11. Plugging that in, we get 25 minus negative 11 minus negative 11. This again should equal 5. So that's equal to, I'm going to go down here, it's a little bigger. So 25 minus negative 11, that's actually 36. Minus negative 11 plus 11. So that's equal to 6 plus 11, which is equal to 17. And that's really not equal to 5. All right. So that one's not a solution. This one, when we squared it, imparted a second solution to our system. X is equal to 0 is our only solution. So again, you always need to check your answers with these. It's very, very common for extra solutions to be added in when you square it or cube it or whatever power you take both sides to.